Okay. All right. So let's get started. All right. Let's go through some of this. Um, so the quantitative reasoning section for the mock exam. Now, there were some hard questions. There were some questions where if you didn't figure out how to do one of the questions, the same type of questions came up again and again and again. So you kind of needed to, learn how to do, you kind of needed to know it. And other than that, there was a lot of questions that were actually fairly, straightforward. So this exam, one of the main things I want you to take away from it is that when you do your gate exam as well, right? Is if something is too hard, if you're struggling with a question, don't waste too much time doing that question. Skip it and then try to do the easy ones first and then come back to it. So let's go through each of the questions, starting with question number one. So Jason took off at a marathon race 1 hour before Aaron. Jason's speed is 10 kilometers per hour, while Aaron can run at 15 kilometers per hour. At what time did Aaron catch up if the race started at 8 a.m.? So basically, okay, I'm gonna mute everyone. By the way, just to reminder, Galaxy Tab A, could you use your real name on the call, please? Okay. So, um, in this question, basically, so right now we have these two individuals. They both start off at the race at this position, and Jason goes off first, right? Jason starts off first. Now it says that Jason started 1 hour before Aaron did, and Jason's speed is 10 kilometers per hour. So my question for you guys is, in that 1 hour, how much kilometers is Jason ahead, or how far away is Jason?
10
That's right. So basically, 1 hour later, 1 hour later, Jason is here. Jason is 1 kilometer ahead, and Aaron is still here. And the distance between them is 10 kilometers. Do you guys understand? Now,
Yes.
Jason, after the 1 hour, Jason will continue to run, right? Jason will so one second. Galaxy Tab A. Sorry, I'm asking you again. Could you please use your real name on the call? Thank you.
Um,
Hello, are you there?
yeah, but I can't figure out how to change my name.
Oh, what is your name? I can fix it for you.
Viga.
Sorry?
Viga.
VA?
IGA.
Okay, I'll change that for you. All right. Okay. All right. So now, after 1 hour mark, Jason will continue to run, and then Aaron will be running after him. But Aaron is much faster. Aaron is 15, can run at 15 kilometers per hour, while Jason only runs at 10 kilometers per hour. Now, how many kilometers per hour faster does Aaron run? And that is 5, right? So if you were to imagine, they're both running like, so they're both running across like this, but Aaron is just so much faster that if they start off here, Aaron will catch up like that. So all you need to keep in mind is that Aaron has to cover 10 kilometers and he is 5 kilometers faster than him. So therefore, in 2 hours, Aaron will catch up to Jason. Do you guys understand?
Yeah.
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 And he already has a 1 hour head start. So how long is Jason running for in total? 3 hours. And if the race started at 8 a.m., 8 a.m. plus 3 hours is 11 a.m. So that's question number one. Question number two. In a CHITS class of 20 kids, it takes them 45 minutes to complete a test. In Nisani's class of 10, 35 minutes, and Dushan's class of 30, 25 minutes to complete the test. What is the probability that one student will complete the test in less than 30 minutes? Well, to find a probability of anything, you just have to divide the number of people who actually did that thing divided by how many kids there are in total. So only 30 kids, only 30 kids were able to finish the test in less than 30 minutes. So that is 30 out of how many students there are. So 20 plus 30 is 50. 50 plus 10 is 60. So 30 out of 60 kids is able to finish the test in less than 30 minutes. So the answer is 30 out of 60. Do you guys understand? Sylvina,
Yes.
is that a no?
Yeah.
Yeah. So Sylvina, to kind of like explain it, basically probability of anything, probability is basically number of times, let's just say X happened, right? Or X can happen, divided by number of all possibilities, right? So to give an example, if you're trying to find the probability of heads in a coin flip, how many like heads are there in a coin flip?
1,
That's right. So you put one at the top. And how many possibilities are there in a coin flip?
2.
That's
Two.
right. So the probability of getting a heads is 1/2. You understand?
Yeah.
Another example is, let's just say my question is asking, let's just say the question was, what is the probability of getting an even number in a roll of a dice? So number of times, the top will be number of times an even number can happen. How many are there? 2, 4, 6. So there is,
3,
that's right. And how many possibilities are there in total?
6.
That's
Six.
right. The answer is 3 out of 6. So similarly, by the way, if you want to, I would recommend you writing this down or like trying to understand this line here. So in this question, we're saying how many, what's the probability of a student finishing the test in less than 30 minutes? Well, how many kids finish the test in less than 35 minutes? Nobody in Achut's class finished it in 35 minutes, 30 minutes. Nobody in Nisani's class finished it in 30 minutes. But all the students in Dushan's class finished it less than 30 minutes. So in Dushan's class, there was 30 kids. And there's a total of 60 students. So the probability is 30 out of 60. Do you understand now?
Yes.
Yeah. So that's how question 2 works. Question 3. Paul has a garage that contains the following cars: 5 yellow Ferraris, 3 green Lamborghinis, 2 orange Bugattis, and 2 blue BMWs. He randomly selects 2 cars from the garage and sells them. If she, sorry, it should be he, randomly selects a third car from the garage, the probability that she selects a green car will be 2 out of 10. Which of the following statements could be true? So basically, it's saying that Paul has already sold 2 cars, right? So how many cars did he have in the beginning?
10. 10.
No.
Oh, 12.
Yeah, 12.
He had 12 cars. And now that he sold 2, he has 10 cars, right? How many green cars did he have in the beginning?
3. 3.
And now he's saying that the probability of selling a third car is 2 out of 10, right? So what does that tell us? What does this tell us? The probability of a green car before was 3 out of 12. Now it is 2 out of 10. So what does that tell us?
He already took one green car out of the garage.
That's right. So out of the 2 cars that he sold, one of the cars must have been
Green one. Green.
green,
Green.
right? So which of the following statements would be true? Option A could be true because one was green and the other was yellow. Option B, it cannot be true. Can anyone tell me why it can't be true?
There was no orange cars.
There is 2 orange Bugattis.
Because
Because it didn't.
Because it doesn't mention the green car.
Exactly. There needs to be one green car that was sold, right? So in option B, there's no green cars being sold, so it can't be B. Why can't it be C?
There's no green car.
There's no green.
And why can't it be D?
Because
there's only
there
one.
were three, and then he only took one. So
That's right. So all of you guys are right. He only sold one green car. So if it can't be both green cars were sold, because if that was the case, the probability should have been 1 out of 10, not 2 out of 10. Do you guys understand?
yeah,
Yes.
All right. The cost of crabs sold at Ronaldo's grocery is $4.85 plus $2 plus, sorry, $4.85 plus $2 per ounce of the weight of the package. Zidane only has $10 to spend on seafood. Which of the following could Zidane use to find the maximum number of ounces she can buy for $10? So basically, it will be $4.85 minimum, no matter how much he buys. And then for every ounce, it's $2. So every $2, for every ounce, it's $2. And all of it has to be less than or equal to $10. Do you guys understand?
Yes. Yes. Yes.
And the answer is A. Now, the only thing you guys might not know about was this line at the bottom. What this line at the bottom means that it's or equal to, right? It could be less than or equal to. Now, even if you didn't know that, you guys haven't you guys learned in school what less than or greater than is?
Yeah.
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 So based off that, you should have been able to solve this question for A.
Excuse me, Melvin.
Yeah.
In the equation thing that you wrote, it says 4.85 plus
Oh.
2x.
My bad. It should
And
be
also it said in the answers that it was C.
yeah. My
And not
apologies.
A.
My apologies. I messed up. It's C. I just looked at it the wrong way.
Okay, thank you.
Yeah, you're correct. Question number. So sorry.
What's the answer to question 4 then?
C. So C is a correct answer. It's just that it's written the other way around. So it's just put this the other way around. Question number 5. Teresa is painting a right cylinder storage tank, right? In order to purchase the correct amount of paint, she needs to know the total surface area to be painted. Which formula will she use if she does not need to paint the bottom or the walls of the tank? Hint, a cylinder surface is essentially 2 circles and a rectangle. So basically what they're saying is that you have 2 circles and then you have a rectangle, and that's your cylinder. And the only thing she needs to paint is just this top part. Right? So what shape is that?
A circle.
That's right. So all you need to do is tell us what the equation for a circle is, and that is pi r squared. This is written incorrectly, if I'm being honest. Like this looks like pi r multiplied by 2, but I think it just didn't print properly, but it's pi r squared.
Yeah.
And everything else is wrong. So, you would assume that's D. Do you guys understand that one?
Mm-hmm.
Okay. Question number 6. Serena came home with a lot of homework. By the way, a fun fact, the question number 6 was one of the first questions in a Loyola booklet ever. Like most of these questions were never used before. Some of them were, some of them weren't. But question number 6 was in our very first booklet back in 2018. How old were you guys in 2018?
I
I
was
was 5.
Wow, that's
5.
very crazy.
was
So you
five.
guys were still
was
wearing nappies, were you?
6.
I was 6.
I was 5.
Serena
was fine.
came home with a lot of homework. She started her English reading at 3:45 and ended at 4:30. She then worked on her history report from 4:30 until 5:15. And after dinner, she finished up with her math worksheets that took her from 5:40 until 6:45. How long in total did it take Serena to do all her homework? So basically, you just have to add up the times, guys. You just have to do the first half was 4:30 minus 3:45, and that is equal
45.
to 5 minutes. And the next one was 5:15 minus 4:30 p.m., and that's equal to 45 minutes. And then the last one is 6:25 minus 5:40 p.m. is equal to 45 minutes. So it's just basically 45 minutes times 3. That gives me 125, which is, wait, no, is it? 90 plus, no, 125. And that should give me,
2
did I
hours.
miss- did I miss something? Yeah, that should give me 2 hours and 5 minutes, right?
Yeah.
25.
135.
It's
Oh,
130.
135, sorry. That's where I messed up. 135. And that should give me 2 hours and 15 minutes, which is B. Got it?
Yes.
Yes.
All right. Question number 7. Well, you guys have done a very similar question in this terms booklet, I remember, about
Yeah.
calculating the goals. Yeah. So over 10 games, Jonathan scored an average of 6 goals per game. If his average number of goals in the first 8 games was 5, he scored the same number of goals in the last 2 games. How many goals did he score in the last game? So basically, it's telling us that over 10 games, he scored 6 goals per game, right? So how many goals has he scored so far in total?
60.
That's right. And then in the first 8 games, he scored an average of 5 goals. So how many goals did he score in the first 8 games?
40.
40.
Yo. So in the last 2 games, he needs to score 20 goals. And what that tells us is that in each of the last 2 games, he needs to score 10 goals each. Do you understand?
Oh, yeah.
Got it?
Yeah.
Questions are easier than I thought they would.
Yeah. Do you know what it is, Mustafa? It's just the stress of doing it under the 2 hours.
Yeah.
And then also like it's all like, yeah, pretty much like the stress is there. That's one big reason. A passenger train left the station and traveled towards a repair yard at an average speed of 30 kilometers per hour. A cattle train left 3 hours later and traveled in the same direction, but with an average speed of 45 kilometers per hour. How long did the passenger train travel before the cattle train caught up? So if you were to draw it out, you have the passenger train going at 30 kilometers per hour, and it's traveled for 3 hours. So if it does 30 kilometers per hour, after 3 hours, how much of a distance is there now?
90
90.
kilometers per hour.
90 kilometers. And then the second train,
Two.
well, all right, sorry. Okay. Snake, turn the mute on before you start arguing. So yeah, when the second train is moving, it's traveling at a faster speed of 45 kilometers per hour. So how many kilometers faster is it traveling at? What's 45 minus 30? Sorry?
15.
15. So basically, it needs to, it needs to catch up the distance of 90 kilometers, and it does that at 15 kilometers every hour. So 15 kilometers per hour. And that is equal to 6. So the question is, how long did the passenger train travel before it caught up? It traveled for 6 hours, plus it already had a head start of 3 hours, which is a total of 9 hours. Do you guys understand?
Excuse me, I don't really get the part from after the 90 kilometers.
Yeah.
And
So basically, Mustafa, imagine if you started running, okay? And you started running at 10 kilometers per hour. Now you have a head start of 10 minutes, so you're pretty far away from me. But then I get on my motorbike and I start driving towards you, right? As I'm driving towards you, you're still running away from me, right? So it's kind of like this. Imagine if both of us are here, right? And then you have a head start, and then you're still running away from me as I'm trying to catch up to you, right?
Yeah.
What happens is I'm faster than you are, so eventually, even though you're running, I'm still going to catch up to you.
Yeah.
So
No, but I mean,
to find out how long it takes you to catch up to me or me to catch up to you, all you have to do is take the distance that there already is between them. So there's a distance of 90 kilometers between them two now, right? You found out here?
yeah.
You understand that? There's already a distance of 90 kilometers. And then the second train is traveling 15 kilometers faster than the first train. Do you understand?
Yes.
So it will cover the 90 kilometers at a speed of 15 kilometers every hour. And it'll take 6 hours to catch up. Do you get it?
Kind of, yeah.
I'll give you another example. Let's just say, Mustafa, me and you, we're working jobs, okay?
Yeah.
You have $10 and I have $0, okay?
Yeah.
What is the difference between me and you right now?
10.
$10 different, right? Now every day we both work, you make $1 and I make $2, okay?
Yeah.
So this is day zero. Day 1, I have $2, and how much do you have? $11. Day 2, I have $4. How much do you have?
12.
12. Day 3, I have $6. How much do you have?
13.
13. Then I have 8. How much do you have?
I have 14.
14. Then I have 10, and how much do you have?
15.
Then I have 12. How much do you have?
16.
Then
14 and then 18.
17. Yeah. And then 16, and then
18.
and then 18, and then 19, and then 20, and then 20. Do you see how even though you had a head start, I caught up to you eventually?
Yes.
And to figure out how long it takes to catch up, all you have to do is how much head start did you have in the beginning? You had a head start of 10, correct?
Yeah.
And how many more dollars do I make than you every day? In this scenario, how many more dollars do I make more than you every day?
1.
$1. So you just have to do 10 divided by 1. And what's that equal to?
1. 10.
10. Good man. And if you count it, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you see how that happened?
Mhm.
So essentially, to find out how long it takes to catch up, you just have to divide the distance that they have by how much faster the other person is.
Yeah.
Okay. All right.
Thank you.
Welcome. Question number 9. Aiden, a stockbroker, gets 20% commission when he sells stocks. He made $30,000 in commission. How much did he sell? So basically, Aiden gets 20% of everything he sells, right? And he got $30,000. So what that means is that $30,000 is equal to 20%, right? And we need to find 100%. How do you go from 20 to 100?
80.
Plus 80.
Multiplied by?
5.
5.
Multiplied by 5. So you do the same thing on the other side. You multiply by 5. 3 times 5 is?
150.
150,000. The answer is D. You guys understand?
Oh,
Yes.
see.
Got it?
Yeah.
All right. 25% of the carrots at Zeba's garden weigh less than 6 kilograms. So basically, if this is 6 kilograms, everything below 6 kilograms makes up of 25% of the carrots. And then 78% weigh less than 8.5 kilograms. Right? So if I'll read all this. 8.5. 70. So everything from here to here, all of this is equal to 78%. And the question's asking how many what percentage of carrots weigh between 6 and 8.5. So essentially, here's my question, if all of this is 75 and this part is 25, how much does this part weigh? Anyone know?
53.
Yes, 78 minus 25. Because if you were to take all of this and subtract this, you would get exactly how much this weighs, right? Do you guys understand?
Yeah.
Yeah. Yeah.
Got it?
Okay.
Yeah, so the answer is 53.
Excuse me, can I please take a screenshot so I can take notes? Thank you.
You should be writing it down.
Yeah, but I'm gonna take
Are you
it
writing
off.
it down as I'm going through?
Yeah, I am.
Okay, okay. All right, no worries. All right, so question number 11. Chettiar is harvesting a cornfield which is 180 meters by 330 meters long. So it's a bit better. Like this. It is 180 and then 330. If a harvester mows strips that are 2 meters wide, how many times must she mow across to get the width? How many times must she mow across the width of the lawn? So basically, Chettiar is mowing like this across the width of the lawn. Do you guys understand?
Yes.
Hello?
Yeah.
Yeah. And then each lawnmower, as it's going across, it is 2 meters wide. So essentially, all you have to do is you have to divide how long she has to go across for, which is 330, and you divide it by across the sorry, I explained it wrong. All you have to do is more across the width. So it is like this because she's technically going this way. So up and down like this, and it is 180 divided by 2, and that gives us 90. Now imagine you made the mistake that I did earlier, which is you decided to do 330 divided by 2. You realize the answer should be 165. And none of the options make sense, which was intentional for you guys. And that's why you know that it has to be other way around and get 90. Do you guys understand?
Yes.
Awesome. Question 12, question 13, question 14, and actually, just those three. They're very, very similar. I think there's one more that's, and then question 18. Oh, and then 17. They're very similar. You just have to take equations, subtract it, and then you'll be able to split. So let's show you how that works. So Sarah's party, 2 chocolate plus 3 Nutella. Let's rewrite it. She says 2 chocolates plus 3 Nutella is equal to 18 cups of sugar. 20 chocolate and then 4 Nutella is equal to 22 cups of sugar. So how much cups of sugar does each cake require, right? You just have to subtract it first. Equals to 22. Oh, why is it loading up on your screen? Can you guys see me written down 22? Oh, it's loading up.
Yeah.
Okay. So you subtract these two equations. So 2c minus 2c is equal to 0c. So we'll just ignore that. And then 4n minus 3n is equal to 1n. And then 22 minus 18 is 4. So that tells us that Nutella requires 4 cups of sugar. And to solve for the rest, you just have to put the value of n in the equation above. So 2c plus 4 multiplied by 4 is equal to 22. 2c plus 16 is equal to 22. And then 2c is equal to 22 minus 16 2c is equal to 6. C is equal to 3. So the answer is C. Can you guys see my whole working out on the screen?
Yeah.
Yes.
Okay.
Yes. Yeah.
All right. Question number 13, 14, and stuff later on, it actually becomes fairly easier because you don't have to do the whole steps to solve it out. I just wanted to show you how the steps work, but then once you figure that out, you can do the rest. Now, can anyone tell me how you could have done this question if you had no idea how algebra works? Yes, Mustafa.
Can you can do it by guess and check?
Good. And what does that mean?
Like so for example, you try the first answer, which is A.
Yeah.
You try 12. You try it on both things. So 12
Yeah.
times 11 plus 6 times 16, and you check it if you got it right or not. And
Okay.
then yeah, you check it.
Perfect. Yeah. So if you wanted to save a, like, I mean, it really depends which one you're good at. I'm assuming most of you guys are not perfectly strong in algebra, but the faster way you could also do it is just by guessing and checking using the answer. So you just put 3 in here. So it'd say 2 chocolate cakes requires 3. Okay, so 2 times 3 is 6. Okay, and 3 Nutella requires 3. So 3 times 3 is 9. 6 plus 9, does that give me 18? No, it doesn't. So then you try option B. And then you try option C, and then C makes sense. So the answer is C. Do you guys understand?
Yeah.
Yes. Yes.
So question number 13, you do the exact same steps as before. For the interest of time, I'm going to skip 13, 14, and 17 and 18, as you guys know how to do it. But if you guys want me to, at the end of the other questions, we can come back and do this again. Okay? All right. So question number 15. There is a hard maths way of solving question 15, but there's also a really simple common sense way of solving it. Can anyone tell me what the common sense way of solving it is? Anyone have any idea?
Just plus them up, just add them up.
Nope. I mean, if you plus them, it'll be 18 hours, right?
I know it might be completely wrong, but so you divide 12 by 6, you get 2, and then because they're 2 people working together, and plus 2, and you get 4.
Nope.
Okay.
It's actually easier than that. If two, okay, if Jordan, sorry, Johan takes, sorry, it takes Johan 6 hours to do it, do the lawn, right? And Jordan takes 12 hours to do the same lawn. If they work together, will they be faster or slower than each other?
Faster.
Now, if that's the case, would option B, C, or D work?
No.
Would B work? Are you so
Right.
Johan takes 6 hours to mow the lawn. If Jordan is working with him, would it take him exactly the same time again to do it?
No.
No, right. Exactly. So the answer is
A.
A. Good. Do you guys understand?
Yes, I do.
Yeah. The hard way of doing it, or the faster, like the maths way of doing it, is kind of like it's like this. So imagine mowing the lawn is like, so actually here's a better way of explaining it. If it takes him 6 hours to mow the lawn, right? What fraction of the lawn would he mow in 1 hour?
1/6.
Good girl, Sylvina. So he can mow the lawn in 1/6 of the lawn in 1 hour. And then what's the speed of Jordan then?
1/12.
Perfect. And if you add them two together, now we can't add them directly, right? So we need to find out their lowest common multiple. And that turns out to be actually 12, because 6 goes into 12 as well. So 2 out of 12 plus 1, because 1/6 is 2 out of 12, plus 1/12 is equal to 3 out of 12. And what's 3/12 equal to?
4, 1
1
quarter
quarter.
or
So if it takes them, if they work together, it takes them, they were able to mow 1/4 of the lawn every hour. How many hours will it take them to mow the whole lawn?
4.
Do you guys understand?
Yes.
Yes.
Okay, so it is 5 o'clock. I'll give you guys your 5-minute break now. I'm going to go take a break as well. We'll come back at exactly 5:05 p.m. Okay, 5:05 p.m.
Thank you.
All right. Welcome, everyone. Welcome back. Hope we had a wonderful break. Let's get started. Okay. So we're now at question number 16, right?
Yeah.
All right, let's continue. A juice box contains 250 millimeters of juice. A bottle contains 1 liter of juice. How many juice boxes contain the same juice as 2 bottles? Well, it's fairly easy. All we have to, 1 second. All right, so all we have to do is convert the liter into milliliters. So how much is 1 liter in millimeters?
1,000.
1,000. So 2 liters is equal to
2,000.
2,000. And all you have to do is 2,000 divided by 250, which is 200 divided by 25, and that's equal to
40.
8.
8.
8. It's equal to 8. And the answer is C. Do you guys understand?
Yes.
Yes.
Question number 17 and 18 is the same as the question type we did before. So we'll come back to that if later once we have time. Question number 19, Sage drove her cabin on the lake and back. It took 0.5 hours longer to go there than it did to come back. The average speed on the trip was 60 kilometers per hour, and the average speed on the way back was 75 kilometers per hour. How many hours did it take did the trip to the lake take? All right, this question is very, very difficult. I think in the whole booklet, like literally in the whole booklet, this question would have been the hardest, right? But you guys can solve it. Are you guys ready? All right.
Yes.
So let's take a look. So the first things first, we need to know how, how speed, distance, and time, all of that works, right? So first thing is, if they started off at their house, go to the lake, and then from the lake they come back, right? Is the distance that they traveled, is it any different?
No.
No, they
No.
traveled the exact same distance, correct? Yeah. But what was different? The two things that were different was the speed that they went. So on the way there, they were slower than the way back. And then the time was different. On the way there, it took half an hour longer. Do you guys understand?
Yes.
Awesome. So basically, let's just write out that as an equation. So we'll say the distance it took. We all know distance is what? What's the equation for distance?
Time, speed, and time.
Yes, speed multiplied by time, right? So let's just say on the way there, it took them, sorry, on the way back, it took them X hours, okay? We'll call that D on the way there. Sorry, we'll say distance to lake took them X plus 0.5 hours multiplied by, and the speed that they went on was 60. Do you guys understand? And the distance back was the time it took, which is X multiplied by 75. Do you guys understand?
Yeah.
Yes. Yes.
Distance from lake. Now, what did you guys just say? You guys told me that distance to the lake and distance from the lake they're exactly the same, correct?
Yes.
So what we can do is we can equal the two equations. X plus 0.5 multiplied by 60 is equal to X multiplied by 75. Do you guys understand?
Yes. Yes.
Multiplied by 75. So I'm going to add a new page. I'm going to explain it there. So let's go back, copy everything. I'm going to do it there. So copy that. Oops. Copy that. Paste. All right, so let's do it here. So 60 multiplied by x is 60x, and 60 multiplied by half is 30. Do you guys understand? Hello?
Yes.
Hello.
Yeah. So, and then on the right-hand side, it's just 75x. Do you guys understand so far?
Yes.
All right.
I do.
Now we move the 60x to the other side. So that becomes, that becomes 30 is equal to 75x minus 60x. Do you guys understand?
Yes.
And then 30 is equal to, what's 75x minus 60x?
15x.
5x.
5x.
15x.
15.
Right, 15x. And then we have to move the 15 across to this side. So 15 multiplied by something gives me 30. So what is x stand for?
2.
Exactly. Good. X is equal to 2. So that means that the time it took to come back, was 2 hours. Do you guys understand?
Yes.
Yes.
So where is the question? How many hours did it take the trip there? So the time it took to come back was 2 hours, but on the way there, it took an extra 30 minutes, right?
So it's 2.5 hours.
That's right. Do you guys understand?
Yes.
Oh.
Yes.
Okay. So question number 20. A team of researchers is studying a special type of self-replicating nanorobots developed for environmental monitoring. These nanorobots can replicate themselves, but with controlled growth to avoid overwhelming the environment. The nanorobot can replicate itself at most once per day. Furthermore, in any given day, either all the nanorobots can replicate or only one replicates, right? So basically what's saying is that the robot could either double, or all the robots could double, or only one of them will double. Do you guys understand?
Yeah.
So the question is saying, what is the shortest number of time for which a single nanorobot can go to 64? So basically, this question, you literally just have to, do the numbers. So you start off with one robot, and then one becomes,
2,
then it becomes,
3,
4.
and then,
8,
and then,
8. 16.
then,
32.
32, and then 64.
628.
so 64. So the number of days it took was 1 day, 2 days, 3 days, 4 days, 5 days, 6 days. Do you guys understand?
Yes.
So it took 6 days. That's the shortest number of time it took to go from one robot to 64 robots. Do you guys understand?
Yeah.
Awesome. Any questions for me?
No.
Excuse me.
Yep.
My iPad went flat, so I didn't get to see question 20 at all.
Okay. So this is recorded. So Mustafa, you can go back and check that out later, okay?
Thank you.
Welcome. Question number 21. What is the shortest number of time in which a single nanorobot could replicate to exactly 100? Now, you can either start from 1 to go to 100, but do you know what's actually easier in this question?
Go from 2.
Going backwards from 100. So what's half of 100?
50.
What's half of 50?
25.
25.
Can you half 25? Exactly.
No.
So you go down only one robot, which is 24. And then half of 24?
12.
No.
Half of 12?
6.
Half of 6?
3.
Can you have 3?
No.
No.
So then it goes
No.
down by 1. And then half of 2?
1.
1.
So basically, on the first day, they doubled. On the second day, only one robot doubled. Then all of them doubled, all of them doubled, all of them doubled, and then only one of them doubled. And then all of them doubled, all of them doubled. So it took 1, 2, 3, 4, 5, 6, 7, 8 days to go from one robot to 100 robots. Do you guys understand?
Yeah.
Got it?
Yeah. I don't
Oh.
understand it.
Which part about it do you not understand, Mustafa?
How it moves up or gets more.
Sorry,
How they get more.
how
Or,
they get more, sorry. I mean,
or
well,
how do you count them?
well, so the question says, Mustafa, that they can all double or they can all go up by one. So that's how we doubled or increased. Yes, Gautam and Connie.
So in question 31, isn't like the 1, 2, 3, and 16, like in the number 1, isn't it supposed to be like 9 days?
No. So it says, what is the shortest number of time in which a single nanobot can double to 100? So the first day, like on day 0, will be one robot, right?
Yeah.
It starts with one robot. At the end of the first day, it'll be 2 robots. Do you understand?
Yeah.
So you don't count the day in which you only have 1 robot.
Oh, okay, I get it.
Yeah. So you only start off when they start doubling. So day 1, 2 robots. Day 2, 3, like that.
Oh, okay.
Yeah.
Thank you.
You're welcome. Connie?
Do you think I could take a screenshot of question 1 to 10 from the other page, please?
Of
Thank
course.
you.
Yes, Nabil? Nabil, you there? Okay. All right. So question number 22. Solutions can be ranked on a scale of acidity. Priya uses a pH monitor that compares the acidity of one solution to another. The pH meter measures the difference in pH levels between the two solutions. Below 7 is acidic, 7 is neutral, and anything above 7 is a base. Priya tested several different solutions. The results shown in the table. For example, the solution with vinegar needs 7 more pH levels to have the same pH as the solution with soap. If the first solution and second solution are swapped, the difference is reversed, as shown with soap and milk. So basically, in the question, as it said, right? When you take vinegar and then you have soap, to go from vinegar to soap, it's a difference of 7 positive pH, as it has to go up by 7. Do you guys understand?
Yes.
Yeah.
And then if you reverse it, so vinegar and soap, we have actually we don't have a vinegar soap, but we have a soap and milk. So soap and milk this way is -4, but then milk and soap is +4. Do you guys see that?
Yeah.
Yes.
Yeah.
So as in what it's saying was that, like, let's just say if you wanted to have, let's just say there's Sylvina and there's Melvin. Sylvina, let's just say, is 1 meter tall and Melvin is 1.5 meters tall. In this way, it's an addition of 50 centimeters. But if it's the other way around, if it's Melvin and Sylvina, it is -50 centimeters. Do you guys understand?
Yeah.
Yeah. When you flip it, you do the opposite as well. Got it?
Yeah.
Awesome. So let's take a look at the question. Which of the following solutions have the highest acidity? All right, so let's take a look. Starting with vinegar and soap. Well, vinegar is clearly more acidic than soap because it tells us below 7 is acidic. So soap is up here, vinegar is up here. And to go from vinegar all the way to soap, it is 7 points. Do you guys understand?
Yeah.
And then you have soap and milk. So the difference between soap and milk is that to go from soap to milk, it has to go down by 4. So milk is somewhere here. It to go down by 4 to go to milk. And that means that to go from milk to vinegar, it's -3. Do you guys understand?
Yep.
And then it says milk and vinegar. Oh, perfect. It tells us here. Milk and vinegar is -3, right? And then it tells us that water and vinegar is also -3. So to go from water to vinegar, so apparently milk and water have the same pH level. So to go from water to vinegar is -3. So out of all of this, if this is base and this is acidic, which one is the most acidic?
Vinegar.
Vinegar. Option C. Do you guys understand?
Yeah.
Awesome. Which one of the following solutions has a pH level between pHs of soap and water? So which one has it in between soap and water? Well, it's not perfect, but the answer has to be C. Because it's not water, it's not soap, and it's not vinegar. So the only one in between, well, it's not in between, they're equal, is milk. Do you guys understand?
Yeah.
Yes.
Mm. So, okay, yeah. What would the pH meter read if the first solution is water with a pH of 7 and the second solution is soap? So if the first solution is water and then it is soap, to go from water to soap, how much difference is it? So remember, we saw here, it is -4 to water. So to go back up, it would be
+4.
+4. So if it reads +4, is that more than 7? No.
No.
Is it less than 7?
Yes.
Is it no change?
No.
Because there's a change of 4, right? And then can we determine this from the information? Yes, we can. So the answer is B. Do you guys
Mhm.
understand?
Yes.
Awesome. All right, question number 25. After doing question number 25, I'm assuming all of you can be doctors, right? You can tell, how to read blood pressure, correct? Yeah?
Yeah.
All right. That's a joke, by the way. I was hoping you guys would laugh.
Ha 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 ha.
Wow, that's so mean. Okay, so what is the threshold clinic blood pressure measurement that indicates a need for ambulatory blood pressure monitoring, ABPM, or home blood pressure monitoring if ABPM is not tolerated? So let's take a look. How do we go to how do we get ABPM or HBPM if it's not tolerated? We need a clinical blood pressure of 140/90 to 179/119. Do you guys understand?
Yeah.
So the answer is
A.
so if less than 140/9. So less
Oh
than
no.
140/9.
B.
Okay, it has to be between 140 to 179, right?
Yeah.
And the answer is B. Do you guys understand?
Yes.
At what clinic BP measurement range is a patient categorized with severe hypertension? So where do we find, okay, severe hypertension. Severe hypertension is when you have greater than 180, correct?
Yeah.
So the answer is
B. C.
C. Do you guys understand this?
Yes. It's pretty easy.
Yep. If a patient's ABPM or HBPM measures less than 135/85, what would be the recommended course of action? So if it's 135, let's see.
Stage 1.
Look at that. We have a little doctor with us. All right, let's take a look at the question again. If it's less than 135/85. So if it's 135, oh no, sorry. If it's less than 135, it is?
Oh, no. No
No
hypertension.
Monitor at
Monitor
least.
at least every 5 years.
Good. All right, I love it. I feel like a senior doctor hanging out with all my junior doctors asking you guys medical questions. All right, so it is monitor every 5 years. Good. What is a recommended action if a patient's clinic blood pressure reading is between 140 and 179?
Offer ABPM or
Or for APPM or
HBPM.
HPPM if APPM not tolerated.
Thank you, Dr. Mohammed and Dr. Pandey Kumar. What condition is characterized by a greater than 20/10 milligram difference between clinic and ABPM measurements? What condition happens when you have a difference of 20 between clinic and the actual, home testing, ABPM testing?
Is it D?
Why? Why is it D?
Um, is
Oh,
What does it say? If you have a difference of 20 or more between clinic and you know, home testing, it is white coat hypertension. Do you guys understand?
yes.
Yes.
Yeah, white hypertension. Do you guys know what that means?
yeah.
So basically, if you have like high blood pressure at the doctor's office, but then when you get home, it's less than what you saw. The reason it's less is mostly because you were really stressed out by going to the doctor. And that's why it's called white coat blood pressure. White coat isn't like the doctor's white coat.
Oh,
Which car model offers the best fuel efficiency per dollar spent? Well, this one was actually really easy. The way to figure it out is actually the cost divided by the fuel efficiency, which is 40. And actually, so the other way around, my bad. It's the fuel efficiency divided by every dollar it takes. And you'd find out the dollar per fuel efficiency. You could do that, and then you find which one has the highest fuel efficiency per dollar. Or you could just look at the question. The one that's got the highest fuel efficiency is 40, and that's also the cheapest. So obviously that one is going to be the most
A.
efficient, right? So the answer is A. Question number 31. If a buyer has a budget of $30,000 for a new car and wants the most fuel efficient option, which car should they buy? Well, any car that's below 30,000, and that is basically compact or sedan, and compact is more fuel efficient. So the answer is once again A, compact. Do you guys understand?
What was the question again for the thing itself?
31.
Oh, it would be, yeah. B. I mean,
32.
A.
How much has the ocean surface pH decreased since pre-industrial CO2 levels based on the latest measurements of 400 parts per million? All right. So the pre-industrial pH was 8.2. The latest level is 400. So at 400, the pH is 8.0. So how much has it increased by? Sorry, decreased by?
0.2.
0.2.
Got it? All right. Coral reef population rates decrease by 10% for every 0.05 drop in ocean surface pH. If the population rate was 100% at a pH of 8.2, what is it expected to be at 7.9? So from 8.2 to 7.9, how much pH do we drop by?
0.3.
0.3. And it says that for every 0.05, it drops by 10%. So how many times does 0.05, or basically 30 divided by 5, how many times is this? 6.
6.
And it's saying that
10.
every one of these times, it increased by 10. So 6 times 10% is
60.
60%. So that means that it went from 100%, right? And it dropped 60%. So now the population is at
40%.
40.
40%.
Do you guys understand?
Yeah.
Oh. If the current rate of increase in atmospheric CO2 levels continue, leading to a decrease in the ocean surface pH by 0.02 units parts per million, what will be the ocean surface pH at a concentration of 550 parts per million? So basically, it's saying that for every 1 parts per million, it drops by 0.002 pH. Do you guys understand?
Yeah.
Yeah.
Currently, so it's asking what will be the pH at 550. So the most latest one we have is 500. So from 500 to 550, how much is it? A difference by
50.
50. And we know that it's 0.002 is equal to, for every 1 parts per million. Now we're at 50 parts per million. So if we're 50 parts per million, How do you go from 1 to 50?
Times 50.
Times 50.
So you do the same thing on the side. What's 2 times 50?
100.
10. What? 100.
100. But then in this case, we have to add the 3 decimal places after. So it'll be 0.100. And that means that you go from the current level, which is 7.8, and you drop 0.1, and you'll get,
7.7.
7.7.
do you guys understand?
Yeah.
Awesome. Question number 35, given that for every 0.1 decrease in pH doubles the stress on marine life, how many times greater will the stress on marine life will be at 500 ppm compared to pre-industrial levels? Okay. At 500 ppm, which is basically 7.8 pH, right? And pre-industrial, it was 8.2. How much did it decrease by, guys?
0.4.
0.4. Now it says that for every 0.1 increase, the stress doubles. So in the first 0.1 increase, it is 2 times greater, right?
Yeah.
Yeah.
Next 0.1, how much is it greater by?
4 times.
4.
The next one, how much is it greater by?
8.
8 times.
And then in the next one, how much is it greater by?
16 times.
16.
So basically, when we dropped when we dropped 0.4 times, the stress increased 16 times. Do you guys understand?
Yeah, 16 times great.
Got it?
Yeah.
Yeah.
All right, so that's all of our quantitative reasoning. We can go through some abstract reasoning. Just give me a minute. I'm going to go turn the fan on. I'll be right back, okay? It's getting hot in here.
Okay.
Oh, poor Louis. So tired.
So now that you've gone through those quantitative reasoning questions, do you still feel like the quantitative reasoning was too hard?
No.
No.
Not really.
It was fairly, straightforward, right? It was like some of the questions were definitely quite hard. But I think it's mostly to do with the time conditions that you had to do, and then being in the exam environment, the stress from there as well. That's what made it so hard. So abstract reasoning, I'm not going to go through every single question because, as I mentioned last week, we've gone through some of them. So we've gone through this page and we've gone through this page. So we'll go through some of these questions in today's class. And I think, that should finish it. And then on the Zoom class, I'll decide which areas I'll want to revise on. Sounds good?
Yeah.
Yeah.
Melvin.
Yep.
Actually, never mind.
Okay. Are you sure?
Yeah, I was gonna ask you how am I meant to know the first page, but you already answered that question for.
Yeah. So you just have to go to Loyola Tutoring's YouTube channel, right? And it's
Yeah.
literally the last video there.
Yeah.
Okay.
कोई क्वेश्चन नहीं था पर इतने कम मार्क्स में फिर भी कुछ भी पूछने को नहीं था क्या
Right. Okay. So question number 17. In this question, normally from the grid questions you guys have done, what is the normal way the pattern moves?
+1 or -1?
No, it usually goes across or it goes
Oh, cross straight.
or down, right? Yeah, so it either goes like this, across the rows, or it goes down the columns, right?
Yeah.
On this question, I don't think it follows a pattern, but let's take a look. So in the first image, we have 4 dots, 5 dots, 1, 2, 3, 4, 5, 6. Oh, it does 6 dots. Next row, we have 3, 4, and then 1, 2, 3, 4, 5. Oh, that's I'm wrong. And then we have 2 dots, 4 dots. This should be
3.
3 dots.
right. Now, option A has 3 dots. Option B has 3 dots. Option C has 3. D has 3 dots. So how do we figure out what the right answer is? Well, there's 2 things. One, Actually, there's only one thing. Basically, you will notice that all the time there was one place that always had a single dot. Okay, that doesn't help us in here, correct?
Yeah.
And if we were to follow how the single dot moves in the first row, it started off here, then it went here, and
Yeah.
then it went here. So it is +3, +3. Do you see that?
Yeah.
In the next row, it started off. Oops, I'm going to redraw this, by the way. Can I rub this map out? Actually, I'm going to do the second row here. Here. In the second row, it started off, started off here 1, went here 2, and it went here 3. So +3, +3. Do you guys understand?
Yeah.
So in the last row, it starts off, well, it finished off here 1. We know it has to go backwards by 3 to here. Sorry, 2. It has to go backwards here by 3, and then it goes backwards here by 1. So the answer
Wait, but
has
Melvin.
Yeah.
In the first pattern, in the last row, it has 2 dots, so you can't tell.
Yes, but what I'm saying, Mustafa, is that in the third image, it's here, right? So here, right?
Yeah.
So we know it has to go backwards by 3 to here. And if we went backwards by 3 in the first image, it's here. You understand? Because we know it's 3, 3, 3, 3. So it has to go 3 again. Do you understand?
Yeah.
So now we're left with the options of B and D. Now, how do we then figure that out? Well, let's take a look at how the other set of dots move, the other set of dots. So the other set of dots starts off here 1, goes here 2, goes here 3. It's just going +1, +1, +1. Do you see that?
Yeah.
Starts off here, goes here, goes here, +1, +1, +1. And the last set starts off, finishes off here, should go here, and then starts off here. Do you see that?
Yeah.
So the answer has to be B. Got it?
Yeah.
Do you guys understand?
Yeah.
Melvin, I don't really understand the last row in both, like the 1 dot and the one that you
So for the how many like positions does the 1 dot move each time, Mustafa?
+3, +3.
All right, good man. So in the last image, it finished off here, correct?
Yes.
So if it goes +3, then to find out the middle image, it has to go back by 3, right?
Oh, yeah.
And then it has to go back by 3. So it's here. Do you understand?
Oh, yeah.
And that's what we did for the other set of dots as well. Got it?
Same. Wait, what about the last row for the
Yeah,
more
so
dots?
the last row, how much for the 3 dots, how much do they normally move by?
+1. Wait.
+1 each time, correct?
Yeah.
So in the last image, it's here. So if it should go -1 to here and -1 to here, and you can see that there. You see that?
Yeah, but oh yeah, I get it now. Thank you.
Yep, awesome. All right, question number 18. Let's take a look. Question number 18. When you draw the line. So this one is a classic stacking question, right? You guys have done multiple versions of this before. Now, the major difference in this is that I'll show you. So the pattern is going down the column. So the top and the top overlap, so it disappears. The bottom, there's no bottom here, so it appears. The middle, there's no middle here, so it appears. But then you're wondering how the vertical lines work. The vertical lines are pretty much a distraction. I don't understand how they're working as well. I mean, sorry, I think like this should have disappeared, but I don't know where this one came from, right? But let's see if that's enough to help us solve the middle one. Top, nothing here, it appears. Bottom, nothing here, appears.
Okay.
Middle, nothing here, so appears. So far the horizontal lines make sense. The top lines, yeah, they're kind of working here. Nothing here, something here, appears. So in the last image, there's a top line, there's a top line here. That means, can there be a top line in the middle row?
No.
No, it will disappear, right? Middle line, there's no middle line here. So what does that tell us about the middle image?
There has to be a
It
middle.
has to have a middle
There-
line.
Yeah.
And then the bottom line, there's a bottom line there. There's no bottom line here. What does that tell us about the middle image?
It
To be a
It has-
bottom line.
Correct. So it has to have a bottom two lines. And the only one that makes sense for that is C. Do you guys understand?
Yeah.
Yes.
yeah.
Question number 19. So I don't know if it's Roman numerals. Let's try it out and see if it makes sense. 2, 3, 6, 4, 5, 20, and then 7, and then 42. Well, there is a pattern, right? 2 times 3, 6. 4 times 5, 20. What's 42 divided by 7?
6.
6.
6. And the answer is D. Got it?
Yeah.
Question number 20. Question number 20, again, we've done so many of these. It's basically just the colors moving around in a loop, right? So all you have to do is draw the blank shape as a map, and then you focus on one color and see how the colors are moving. So I'm going to draw the blank square, and then I'm going to have my square 1, square 2. Oh, actually, what I will do. Yeah. Square 1, square 2, circle, 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 circle. And then, actually, sorry guys, I'm just really bad at drawing. I think I'm going to make my map easier to visualize. Circle, 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 circle. Okay, this is my map, right? The empty one. Would you guys agree?
Yeah.
Not
Yeah.
perfect, but it's pretty much the same shape, right?
Yeah.
So let's focus on the black. The black starts off here, then it goes here. Where does the black go next? It goes here, and then it goes here. All right. Then to continue on from there, let's go back to what color, actually, what gray that was in this position, right? When gray was in that position, it went from there, it went up to here, 5. And then from 5, it went up to 6. Do you guys understand?
Yeah.
And then again, we don't know what happens next. So let's look at the top line here. The striped went from this position, it went here. So 7. And then from this position, it went back to the left position. So the pattern is essentially the colors start off here, goes down, down, down like this, goes back up here, and then goes across. Do you guys understand?
Yeah.
Oh, yeah.
Yep. So the next answer should have a black at this position. So we can cross out B. It should have a gray in this position. So we can, oh, wait, it doesn't help us. I mean, we can cross out C because all the background has to be white. Then we know the stripe has to go down here. So we can cross out A, and we're left with D. You guys understand?
Yeah.
Yeah.
Question number 20. So again, let's try the pattern going across. So the arrows starts off here 1, 2, 3, +1, +2. Do you guys understand?
Yeah.
Yep. Let's try the next, the bottom row. The bottom row, it starts off 1, 2, 3, +1, +2. Do you guys understand?
Yes.
Yeah.
The arrow in the last, in the middle image has to be, starts off here +1, +2, so +1, and it should be +2, facing bottom right. Do you understand?
Yeah.
Yeah.
Yeah, and could you take a seat at a table and make sure you take notes? Because this is still a proper class, right? Even though it's online, you still have to take proper notes and treat it like a class.
Excuse me, Melvin.
Yeah.
I thought it would be D because it's just moving anti-clockwise.
Oh, I'm so sorry. I'm so sorry. Why nobody else called me out on that? Yeah, I don't know why I went clockwise. Sorry. So let me draw that again. Good spot, Mustafa. So it starts off here. One. Oh no, I was right. 1, 2, 3. So it goes 1, 2. No, I don't understand, Mustafa. So in the top one, it went -1, -2. Then here we went -1, -2. So with same thing here, we go -1, -2. Like,
But
isn't it?
if it's in the bottom right, then it could be B or C.
Yeah, I'm not finished yet. I was just telling.
Oh.
By the way, Diane, you still have to have your camera on. I told you to sit at a table and take notes. I didn't say turn the camera off. So guys, I know it's an online class. I know you guys are tired, but you still have to treat it like a proper class.
Excuse me.
Yeah.
I just can't move anywhere because this is a kind of like a table, but it's in front of my couch, and my plug is in right now, and I can't move anywhere because where the rest of my tables are, there is no plug.
I
But
understand.
right now,
The
I'm
reason
taking notes as well.
what I was saying was that you shouldn't be lying down on your couch and just watching the class as if it's like a show. Like you should be sitting there and learning, mostly because you guys have, I think, less than 100 days left of the GATE exam, and I want you to take this class seriously.
Yeah, but
right?
I'm also taking down notes.
I understand, but I'm just saying, like for example, if you look at all the other students, they're sitting doing the work properly. So again, one of the reasons I tell you guys to have your cameras on is because as a teacher, I can't see you guys are clearly, right? Normally in a classroom, I can see if a kid's paying attention or not. And when I was looking at you, you clearly seem to just like lie down there and watch me. And that's not acceptable. That's why I said that. Like if you were in school right now, would your teacher be okay with you lying down on a sofa?
Yeah.
Exactly. Connie? You have your hand up?
Yeah. Do you think I could take a screenshot of the page so then I could take
Yeah.
notes?
Sure. I'm not finished with this page, but when I'm finished, you can take a screenshot.
Thank
Right.
you.
As Mustafa mentioned correctly, we have option B and C. Now, to figure out between B or C, what is the correct answer, basically the next pattern, Mustafa, is what is the other feature that's changing across the row other than the arrow?
The stars.
That's right. So, and if you notice, the stars only move when an arrow points towards it. So the star is pointing at this arrow, this star, and it changes. The arrow's facing in the middle, so both of these change, right? Arrows facing this way, so both of these change. So arrows pointing here, so the only star that should change is this bottom left one, and the answer has to be C. You understand?
Right. Oh, and then. Oh yeah, it would be C.
Question number 22. In question number 22, there's two things that are moving. So the one is the white line and the other one is a space line, right? So how many possible how many positions does the white one move? The white one goes 1, 2, 3 to here. It goes 1, 2, 3 to this position. It goes 1, 2, 3 to this position, and then 1, 2, 3 to this position. Do you guys understand?
Yeah.
Yeah.
So the answer has to be A, B,
B, C, B, D.
and then the empty space, it goes 1, 2 to here, 1, 2 to here, 1, 2 to here, and then 1, 2 to this bottom left. And the answer is A.
A.
You guys understand?
Yeah.
Yeah.
Awesome. Question number 23. Again, this is one of our color movement questions. So let's draw our map again for this. So we have, position 1, 2, 3, 4, and then we fill it in. So the gray, let's focus on the gray here. So it starts off here 1, goes to the background 2, goes here 3, goes here 4. And then let's focus on this black here. That starts off here. From 4, it goes down here 5, and then it goes back around. So the pattern is it starts at this position, background, this, and back to this. Do you guys understand?
Yeah.
So in the next image, this gray has to go to the bottom. So it can't be C, can't be B. And then the black has to go to the top. That's correct. And it has to be A. Do you guys understand?
Yeah.
Yeah.
Yes.
And then question number 24, let's take a look at how does the arrows help? Down, down, down. Well, I guess the arrows could help. So the arrows in the top row, it starts off 1, 2, 3. It goes backwards by 1. In the second row, the arrows go 1, 2, 3, minus 1, 1 each time. And in the bottom row, it starts off 1, 2, it should go 3. The answer has to be A or D, correct?
A or
Yeah.
C.
Sorry, B or C, my bad, B or C. And then let's take a look at the black dot. So it goes 1, 2, 3, 4, 4 positions, and 1, 2. Okay, let's see if that makes sense again. 1, 2, 3, 4 positions, and 1, 2. Does that make sense?
Yeah.
The next one
Yeah.
is 1, 2, 3. Oh, we wasted time. They're both the same. Let's just focus on the gray then. So gray goes backwards 1, 2, 3, and then minus 1. 1, 2, 3, and then minus 1. So it should be 1, 2, 3, and it should go minus 1. And the answer is C.
C.
Do you guys
Yeah.
understand?
Yes.
All right. There you go. You can take a screenshot of it if you'd like.
Melvin, can you please go to the page before, please?
Page 4. Page before. Oh,
The
okay.
page before.
Yeah, yeah.
And the one before it as well.
Mhm.
These are the ones that I missed because I wasn't in the thing itself.
Okay.
In the Sunday thing. Thank you.
Welcome. Question number 25. So question number 25.
Can I quickly take a screenshot?
Yes, of course. Which page?
Do you think I could take it off from question 1 to where you're up to now? Because last Sunday I didn't get the screenshots.
Melvin, for
Excellent.
question 24, is the answer C?
Let's just double check once I get there. Are you done?
Yep.
'24, the answer is C, yeah.
Okay.
Melvin?
Yeah.
How much questions will there be in the real gate test?
Exactly this many questions. 35 in each section and then 1 writing.
Okay.
Will they be
Thank
as
you.
hard as this mock test?
Okay, good question. Reading, abstract reasoning, and then writing will be, yes, it'll be the same difficulty. Maths, I think it'll be slightly easier.
Easier than this.
Yeah.
Oh.
The main issue for you guys, it won't be the difficulty of the questions. It's going to be the time. Finishing it on time. If I were to give you guys a tip, so we're gonna go through this again in the final term, right? Once again, we're going to go through this in the final term. So the plan is essentially when you're doing the gate test, right? Here's what I'll tell you. First things first. Okay, let's just do a quick recap of this because it might be useful. Like the more times I do it, the more you're likely to remember. First things first, let's do the easy solutions. So this reading context, how much reading do you have to do? 1.5 bits, right?
Yeah.
And then
Yeah.
how many questions do you get to do for that much reading?
6.
6.
Then take a look at this. You have pretty much 7 lines of text, right? Literally 7 lines. How many questions did you have? 15 all the way to 26. 11.
11.
So which one was a better use of time? This text or text 1?
This text.
Exactly. The reason being, you for the same amount of time it takes you to read this text, you'll be able to answer double the questions. Do you guys understand?
Yeah.
So when you
Yeah.
gate exam, you should be looking at things, right? You should be like, oh, okay, which one will give me the best value for my time? So that's trick number 1. And same thing, quantitative reasoning. All of this, one question, and suddenly you have, take a look at, for example, hypertension. You have 1, 2, 3, 4, 5 questions. That's super easy, right? Oceans solutions, you have 1, 2, 3, 4 questions for one text, right? So that's one basic tip I'll give you. Tip number 2 is when you're doing abstract reasoning, do the easy questions first, right? So for not just abstract reasoning, for all the other sections as well, do the easy questions first. So for example, if you look at abstract reasoning, you know that questions like, let's take a look.
Number 1.
Not number 1. I want to take a look at like 19 should be straightforward, right? Because it's either going to be numbers or number of straight lines. Or if you look at question number 25, it should be straightforward, should be theoretically, because there's only like 2 things to focus on, right? A smiley face and a triangle. Sorry, a diamond. But then on the other hand, if you look at question number 11, it might take a bit of time because you don't know how these 4 dots that look all the same is moving. Or if you look at question number question number 29, you have 2 colors, but you don't know how each of them are moving. So that's going to take a bit of time. So you should do the easy questions that you know for sure you'll be able to do first before doing the hard ones. And if you get stuck, if you're starting to get stuck, or if you look at a question and you think this is going to be hard, skip it and come back. Do you guys understand?
Yeah.
Yeah.
Those are some tips I would give you. We'll have a lot more of those. We have like a full session of that literally 2 days before your gate test that I'm like working on at the moment as well. All right, guys. So that's it for this term. So today was the last class for this term. It was really awesome teaching you guys. It was really fun meeting you. Most importantly, I'm really proud of how much improvement some of you have made. So for example, a special shout out goes to my friend Zainab, who improved so much from the beginning till now. And same as Mustafa, you guys improved so much. I remember at the beginning, like literally every single question you would ask me to do it again. But now you're jumping up and telling me, hey, Melvin, you're the one who messed up. This is how you do it. So you guys improved so much. But then everyone else who actually participated, like Hannah, like Sneh, like Connie, Dian, who else contributed? Like Darshan, Sylvina, Gautam, Jay, Myra, like, and the rest of you guys are kind of quiet. And then Pranit, and I think maybe a few students were in today's extra class. But yeah, you guys did really, really well. And I really wish you could come to our physical classes, but it was a pleasure teaching you guys. Yes, Connie?
Is there a Sunday class for this?
There will be. So that'll be the final class for all the students, but today is technically your final class for this term. Now we do have term 1 classes that's starting in January. I hope to see most of you there. Otherwise, we still have the online version as well. If you can't travel, like Mustafa, who lives in Kalbari, right? Kalbari? Karata, yeah. And then Connie, who lives in Hungary.
Do you think I could quickly take another screenshot of the last page from 25 to
Oh, we didn't finish those questions, Connie. So I'll go through that on Sunday if you come join.
Melvin.
Yep.
How am I meant to join into the Sunday class if I don't have the link or that?
The link is the same as this.
Oh,
They're the
Is
same
it-
link.
okay. Is there gonna be anything different on the Sunday class than this, or
Yeah. Sunday, I'm going to finish off the rest of abstract reasoning and then maybe some other random questions.
Yeah.
All right. Well, it was really nice meeting you guys. See ya. Have a happy holiday.
Yeah.
Yeah,
Thank you. Goodbye.
thank you, Melvin.
Thank you.
Melvin,
Bye-bye.
I
Yeah.
have two
Thank
questions.
you.
Bye. Merry
Okay.
Christmas.
All right. And I heard my name a few times. So what's your questions?
So my question